Let's go through how to work with a redox reaction prediction. In a redox reaction prediction, the identifying feature to tell us that it's a redox will be in the language of the problem. If a problem has something in it where it indicates we have an acidified solution, or it might say something is under acidic conditions, or it may say a basic solution or basic conditions, this will be an indication that our reaction is going to be a redox reaction, and we have to address the reaction as a redox reaction. We need to identify the ions in the solution that may be functioning as our oxidizing and also our reducing agents. In this case, in all likelihood, it's going to be our chloride and our permanganate. Potassium and sodium, oftentimes in redox reactions, function merely as spectator ions and drop out of the actual chemical equation. To solve our redox reaction predictions, we need to utilize the table that has common oxidizing agents and also common reducing agents in it. We're going to identify our ions that are functioning as our oxidizing and reducing agents, our chlorides and permanganates. If we look at the table, we can see a common oxidizing agent under acidic conditions is permanganate ions. A common reducing agent is halide ions, which would be chloride, which is from the halogen family. This gives us our reactants that we have, the permanganate ions reacting with the chloride. The permanganate is going to function as the oxidizing agent. The chloride is going to function as the reducing agent. Looking at our table, we can see that permanganate, when it's working as an oxidizing agent, is going to produce Mn2 plus ions as a product. The chloride ion, or free halide ions, acting as a reducing agent, is going to make some free halogen as a product, which in this case from chloride, that means it's going to make elemental chlorine. This would be our reaction that we have of permanganate plus chloride. Let's try another redox reaction prediction. Here we have something where it says concentrated nitric acid mixed with potassium sulfite. Oftentimes in language, if a problem says something such as concentrated nitric acid, hot concentrated sulfuric acid, or things of this nature are indicative that the reaction again is going to be a redox reaction. So the language of the problem gives us a tip that it's going to be a redox reaction prediction. To continue in the problem, we need to access the table again with the common oxidizing agents and reducing agents. And we see here that we have concentrated nitric acid is one of our oxidizing agents, and potassium sulfite, right here we have sulfide ions, are a reducing agent. So we've identified our reactants in this redox reaction. At this point, what we'd have is nitric acid, and nitric acid is written as separate aqueous ions because it's a strong acid and the ions will exist separately in solution, plus our sulfide ions. The nitric acid is going to function as our oxidizing agent. The sulfide ions are going to function as our reducing agent. Looking at our chart, the nitric acid is going to produce NO2 as a product when we're using concentrated nitric acid. And the sulfide ions, when functioning as a reducing agent, are going to produce sulfate ions. So we'll turn into SO4 2-. To complete this reaction prediction for a redox, we'll put in waters on the opposite side of our H plus ions. This will be how we can use our chart of oxidizing and reducing agents to predict the products that we're going to get in a redox reaction. In our next example, again we see language that says an acidified solution. This again will tip us off that this is going to be a redox reaction. We also see dichromate, which is a very common oxidizing agent, and then we see some metal ions that can have more than one charge. Tin 2 can also exist. Tin can exist as a +2 or +4. The multiple positive charge metal ions oftentimes appear in redox reactions because when they change charge, they're being oxidized or reduced. Looking at our redox chart again, we can find our reactants are going to be dichromate, Cr2O7 2-, and tin plus 2 ions. Our dichromate ions are identified as our oxidizing agent. Tin 2, which are also known as Stan-Us ions, would be some of our metal Us ions down here. The Us ions are of the lower charge, so they can function as reducing agents. Using the chart, we can see that our products, the dichromate functioning as an oxidizing agent, is going to form Cr3 plus ions. And our metal Us ions turn to metallic ions. So the Us turns to an ic. So tin plus 2, which is Stan-Us, is going to turn into Stan-ic ions, which is SN4 plus. And this would be our redox reaction.